Now, at noon, ship A is 50 kilometers north of ship B. So this is a 2012 question B. So what we have is ship A north of ship B. A, B, 50 kilometers. Ship A is traveling southwest. So southwest is which way, guys? Southwest, bottom left, yeah? Actually, I like my dotted lines here. Bottom left at what speed? 24 route 2. Okay, and what way is ship B? Ship B is traveling due west. Ship B is traveling this way, and it's saying 17 kilometers an hour. Find the magnitude of the direction of velocity B relative to A. Okay, guys, this is marks on a platter. This is 10 marks to write down one thing. All you gotta do is this. You just gotta write down phi BA, velocity of A relative to B, equals phi B minus phi A. The next thing you gotta do is figure out what is phi A and phi B in terms of I and J. So easy, right? Phi B is minus 17 I think. Sorry, phi. I'm looking at the wrong one. Never mind. I'm looking at it. It's minus 17 I. Everybody alright with that? And then, what is phi A? Phi A has to be broken up into its components. So it's going this way at 45 degrees. So, and it's going 24 root 2, yeah? So it's going to be 24 root 2 cos 45 and 24 root 2 sine 45. And I'm just going to get rid of that because I know sine 45 is 1 over root 2. I know cos 45 is also 1 over root 2. So it's just going to make it a double 24. 24 across, 24 down. Anybody want to tell me what the IJ is for 24 across, 24 down? Minus 24I, because it's going left, and minus 24J, because it's going downwards. Everybody alright with that? Now, phi BA, therefore, is going to be phi B minus phi A, which is minus 17I. I'm going to multiply phi A by minus 1 to get 24I, 24I, and my plus 24J. My overall speed, therefore, is going to be minus 17I plus, wait a minute, I'm wrong with that, plus 7I plus 24J. That makes perfect sense, doesn't it? Because this one is going across at 24 and down at 24. That means it's going 24 closer every time. Right? Because velocity of B relative to A. A is the second letter. Therefore, A is considered stationary. So A is considered stationary. So because A is in real life, A is approaching it at 24 kilometers an hour. 24 kilometers downwards every hour. If I keep A stationary, that's the same thing as A seeing B coming towards it at 24 in that direction. 17 and 24 means that A is getting away from it. Or sorry, A is actually going minus 7 away from it every second, but because we're keeping A stationary, that's the same thing as B going to the right of it, 7 every hour. I think we're almost overthinking it at that stage, so look, we'll just leave it there. And what we have next is how far away at the start? 50 kilometers apart, and that's phi BA. The key thing to remember is this, guys, alright? If you really want to simplify it down. Both of them are 50 kilometers away from each other. You choose, either gets chosen for you, or you choose one of them to keep stationary. That's A, that's B. In this question, It's the one that comes second. Relative to is the stationary one. I indicate that A is stationary. Just put an X through it. A is not moving anymore. The velocity of B relative to A. The velocity of B relative to A starts at the point B. What direction is it going and how fast is it going? Okay? What's 7i plus 24j? What direction is that? Northeast. So it's this way here. It has an I component and a j component. It's 7 and 24. If I do Pythagoras' theorem, I reckon it comes out at 25. Would everybody agree with that? If not, I'll just do it here. Yeah, thank you. Now, I'm going to get the angle, I'll call it the angle x. Anybody tell me what the angle x is? Tan x equals 24 divided by 7, which is what? The angle x is? Anybody? Nobody. Thank you. X is 73 degrees, 73.774. Now, that's good angle to know, helps you with the drawing. I can also figure out what cos x and sin x are, just to prevent any rounding errors. I can figure out that cos x is 7 over 25, and I can figure out that sin x is 24 over 25. That's great. Now, what I'm going to do next is, I'm going to group this, and I'm going to draw. I'm going to draw B going across. Now, as I said earlier, we're just going to, and we're looking for the, at A and B can exchange signals when they are no more than 20 kilometers apart. At what time can they begin to exchange signals? How long can they continue to exchange signals? Is what we're trying to find out. Alright? So, I usually like to find the closest distance anyway. Okay? And I'll explain that in a second. So, we're going across at this angle here. This is technically angle X. When it's at its closest point, what's the angle compared to that? Sorry? 90 degrees. Goes straight up like so. Okay? Now, if that's angle X, and it's going that direction there, what does that make this angle in here? Sorry? 90 minus X. Now guys, if it's 90 minus X, what happens to all these values? They all flip, don't they? So I'm just going to use a new letter. I'm just going to call it angle Y. If that's angle X, that's angle Y. So therefore tan Y will be what? 7 over 24. Cos Y will be 24 over 25. Because if that's angle X, that's angle Y. And then sin Y will be 7 over 25. Okay. I'm going to calculate this value D. What side do I know? These are all distances, by the way. No more velocities here. So what is the blue line? 50. Okay. If I want to find the closest approach, just out of interest, what would this be here? 50 sine. It's 50 sine Y. Because you're looking for the so 50 times 7 over 25 is 140, is it? No, it's not actually. What is it? 14? I think it's 14, okay. Just verify that it's 14, will you? Okay. What's the other length? So 14 kilometers is the closest you're going to get. Is that alright? What's the other one? What's the other length? How far did we travel? How far did B travel relative to A to get to this closest distance? So this is B traveling relative to A, and eventually it stops here and it gets to the closest distance. That's 48 because it's 50 times cos Y, which is 50 times 24 over 25, which is 48. So by having this extra information here, what this helps me picture is this. Initially, we're 50 kilometers away. At a certain point in here, what's going to happen is we're going to reach what distance away? Can anybody tell me? I'll denote it in green. What distance is that green line? According to the question, we want it to be 20. So you start at 50, your B is travelling relative to A, it hits here, it's now 20 kilometers away from A. It continues to a point where it's now 14 kilometers away from A. That's its closest point. Then it continues to travel away from A until it reaches another point at which it's 20 kilometers away. This is an isosceles triangle. Okay? So, what I got to find out is I've got to find out some extra information on what am I looking for? I know that distance there, don't I? That distance there is 20 each time. And now my little central distance is coming in really handy. Because what can I do to get the, I'll make it a blue distance. What can I do to get that blue distance there? Pythagoras makes it so easy, right? So this blue distance, it's going to be 20 squared equals 14 squared. I'll need another letter, let's call it D, plus D squared. 400, what's 14 squared? Is it 256 or 196? I always get it mixed up. Is it 196? Okay. And what's D squared then? 14.28. So it's the square root of 204, yeah? Which is 14.28. Give me 3 decimals on it, because you'd never round off to 2 to the very... 28? 2851. Yeah, that'd be... by Gary giving me that, it means I don't have to do any rounding off to the very end. Okay? So, 2 root 51. Okay. So, here's the interesting thing, alright? So that's 2 root 51, yeah? It's 48 kilometers from the red dot to B. 2 root 51 of that is within 20 kilometers. So if I get 48 kilometers and take away 2 root 51, what distance will that give me? It'll give me the red distance from here to here. It'll tell me how far did I need to travel, or how far did B need to travel relative to A to get to the point at which it's 20 kilometers away. So would somebody give me that, please? Just whatever the calculator spits out as. 48 minus 2 root 51. We can 717, right? 33.717. Now, we want the time it takes for this to happen. Does it say at noon? So what time? So we're looking for time. Time equals distance over speed. This is the distance. I need the speed. Okay? So what we're going to do here is this. We have to find out how fast we're going. Remember we did it earlier. 7 and 24 gives you a hypotenuse of 25. This means that this line here, which I'm going to... This line here, I'll make it really obvious. You're going 25 in this direction. You keep moving at 25 kilometers an hour. That's B moving relative to A. Everybody got that? What distance did we say we had to cover again? We had to cover 33.717. So distance over time will therefore be 33.717 divided by 25. What's that in the calculator? Now there's a little trick here we can do for this. Keep it there, divided by 25. That's in a metric system, right? Anybody suggest a quick way to change that into minutes and hours? That button there, believe it or not. Is that what you said? What'd you say? Say what are you gonna say? Okay, you can do that. But do you know angles degrees, angles, and minutes, yeah? They operate on a 60 system. They operate on the same system as time. So, technically speaking, a little cheat here is this. If I press this button here, 1 hour, 20 minutes, 55 seconds. Okay? So, you can just say it's 1 hour and 21 minutes. Now, it doesn't ask me how long. It asks me what time. When did we start? We started at noon. It's in the question. We went an hour and 21 later on. So that's 13:21 when signals start. Now we have to find out when do signals end. Okay? I have no idea what that is. Now, how long is a time question? Can they continue to exchange signals? How long is that? How long is this region here, the blue region? Can anybody tell me how long the blue region is? It's 2 root 51 plus another 2 root 51, which is 4 root 51 in distance. This 4 root 51 is got to be divided by what? Your speed of B relative to A, which is your 25. And once again, that's your time taken. I reckon we can leave this in decimal form because it doesn't specify hours and minutes, and it's not looking for the time. So I can leave it in decimal form if I want. Okay, so 4 root 51, all that divided by 25, and what I get is 1 hour, 1.14 hours, or 1 hour, 8 minutes and 32 seconds, 1 hour, 9 minutes, or 1.14. So I'll go for 1.14 hours, or 1 hour, 9 minutes. Okay.